In this video, we will learn about the abstract factory design pattern and how to implement it using C++ code. Abstract factory is a creational design pattern. A creational design pattern is a pattern that is used to create objects. The abstract factory pattern lets us create a group of related objects without specifying the objects directly. For example, we could have objects of different colors that we create using the abstract factory pattern, as you will see in the example later in this video. Each design pattern solves a commonly occurring problem in software development. In this case, abstract factory solves for when we need to create a group of related objects like vehicles, and have several variants of those objects, for example, if the vehicles could be different colors. We need a way to create individual vehicles so that they match other vehicles. In other words, if a person is purchasing a red car, they may want a red plane to match. There are 5 main types of classes involved in this pattern. The abstract factory is an interface that contains the methods for creating the abstract products. Each factory will implement the creation methods of the abstract factory. Abstract products are interfaces for related products, which then get implemented by products. And finally, the client is the part of the program that actually calls the factory code and product code to do things in the program. For example, let's say we wanted to create a factory that creates vehicles, some red and some blue. Each car vehicle will have a plane of the matching color to go with it. So a red car will be paired with a red plane, and a blue car will be paired with a blue plane. The abstract factory would be an abstract vehicle factory. Implementing the abstract vehicle factory would be a car factory and plane factory. The abstract products in this case would be the blue vehicles and red vehicles, and the concrete products, the implementations of these abstractions, would be red cars and red planes, and blue cars and blue planes. The client would have the ability to create red and blue vehicles. Now that we understand the concept of the abstract factory design pattern, let's learn how to implement it using C++ code. We are going to work with strings in the design pattern examples that we implement in this section. So let's include the string header file at the top of the code. First, we will create one of the abstract product classes. Let's create a class named redVehicle. Inside of this class, we will use the public access modifier and have a virtual destructor for the class, as well as a virtual function that returns a string named move. Next, we will create the concrete product classes, which will extend the abstract redVehicle class that we created. Let's have a class named redCar that extends the redVehicle class. Inside of here, we will implement the move function and specify that we are overriding the move function by using the override keyword. Inside of this function, we will return the string redCar is driving. After that, we will create a class named redPlane that extends the redVehicle class. It will override the move function, and inside of here, we will return the string redPlane is flying. After that, we will create another abstract product class named blueVehicle, which will have 2 public functions, a destructor, and a virtual function that returns a string named move. Then we will create a blueCar class, which will extend the blueVehicle class. Inside of here, we will override the move function, and inside of it, we will return the string blueCar is driving. Then we will have a class named bluePlane that extends the blueVehicle class. It will override the base class's move function, and inside of this function, we will return the string bluePlane is flying. Next, we will create a class named abstractVehicleFactory that has 2 public virtual functions. The first will be a virtual function that returns a red vehicle named createRedVehicle. Then we will have a virtual function that returns a blue vehicle named createBlueVehicle. After that, we are going to create a class named CarFactory that extends the abstractVehicleFactory class. Inside of this class, we will override the base class's createRedVehicle function, and inside of here we will return a new red car. Then we will override the createBlueVehicle function, and inside of here return a new blue car. Next up, we will create the planeFactory class, which will extend the abstractFactory class. Inside of this class, we will override the createRedVehicle function, which will return a new red plane, and the createBlueVehicle function, which will return a new blue plane. Next, we will create a function with a void return type named client code that takes in 1 parameter, a const abstract vehicle factory named factory. Inside of this function, we'll create a pointer to a red vehicle named redVehicle, which we set equal to factory.createRedVehicle. Then we will have a pointer to a blue vehicle named blueVehicle that we set equal to factory.createBlueVehicle. After that, we will output a tab, and then the result of a call to the red vehicle's move function, followed by a new line. Next, we will output a tab, then the result of a call to the blue vehicle's move function, and then a new line. After that, we will delete red vehicle and blue vehicle respectively. Time to test our code. Let's go inside of C++'s main function. First, we will output testing car factory, and then a new line to the console. After that, we will create a pointer to a car factory named F1 that we set equal to a new car factory. Then we will call the client code function and pass in F1. After that, we will delete F1. Next, we will output the string testing plane factory to the console, followed by a new line. We will create a pointer to a plane factory named F2 that we set equal to a new plane factory. Then we will call the client code function and pass in F2. Finally, we will delete F2. When we run the code, notice that our factories correctly created the cars and planes, and that the move function of those objects was called as we specified. Using the abstract factory pattern is recommended when your code needs to work with many related products, but you want to have the flexibility to not depend on the implementations of those products. It is possible that they are not known in advance, or you want to make the code more extensible for the future. Advantages of this pattern are that you can be sure the different objects you are getting from a factory are compatible with each other. You avoid writing tightly coupled code. Each piece of code follows the single responsibility principle by doing one thing and doing it well. And you can introduce new variants of products without breaking the existing code. For example, it will be easy to create green vehicles like green cars and planes by adding them to our existing factory implementation. The drawback of the abstract factory pattern is that the code will become more complicated since this pattern has several classes and interfaces that are used when implementing it.